Hey everyone, we're going to use the properties about quadrilaterals that we have learned in class to complete 1 through 12 on the back of the Topic 22 packet. These are all mixed practice, so it's going to cover quadrilaterals such as the parallelogram, rhombuses, squares, kites, rectangles, and the isosceles trapezoid. So for number 1, 2, and 3, we want to fill in every single angle measure in the figure below. We are indicating that it is a rhombus. So in being a rhombus, we've got some properties that we know. We know that opposite sides are parallel, we know opposite sides are congruent, we know opposite angles are congruent and consecutive angles are supplementary. We also know that the diagonals bisect each other, but something that is specific to a rhombus and a square, but working with a rhombus for this one, is that the diagonals are perpendicular. So we know that the diagonals are perpendicular. So with that, I know that all 4 of these angles here are 90 degrees. So we filled in those 4. We know that those are 90 degrees. We also know that the diagonals bisect the opposite angles. So in pink here, I'm going to highlight these 4 angles are all going to be the same because the diagonal here bisects each of these opposite angles. And then the same is going to be true for these 4 angles. Those 4 angles are also congruent. This diagonal IK bisects this angle and this angle here. So, if all 4 of these pink angles are the same, and we know that this one is 28, that means that all 4 are 28. And that just leaves these blue angles left to find. Well, if we think about this in terms of just one triangle, so if I were to ignore everything else in the picture, so ignoring all of those pieces, and if we see here we've just got that one triangle, I know that the sum of the interior angles in a triangle is 180 degrees. So if I took 180 and I subtracted the 90 and the 28, we would be left with 62. And that would mean that this angle is 62. Which would then give away that these other 3 angles, the ones that are bisected here, this whole angle is bisected and congruent, that means this one is 62, as is this one and this one. So we use the properties that we knew about a rhombus, specifically that the diagonals are perpendicular and that the diagonals bisect the opposite angles to fill in the missing pieces for this one. Looking now at number 2 for the kite, we know one of the properties of a kite is that we've got one pair of opposite angles that are congruent. And specifically, the one pair is the angle in between the 2 consecutive sides that are not congruent. Notice how this has 1 tick mark, this has 2 tick marks, the angle in between those. So these 2 are congruent, and those are the only 2 that we need to fill in. So if this is my x, this is also going to be x because I know that they're the same. I know that the sum of the interior angles of a 4-sided figure is 360. So I can take x plus this 92 we have here plus the 62 and set that equal to 360. So when we go through and we solve this entirely, we end up finding that x is 103. So I could fill that in to my picture. X equals 103 degrees. Looking at the square, we know that all 4 angles inside the square here, and what I mean by these 4 angles, they're all 90 degrees. The diagonals are also perpendicular, so these are all 90. If we bisect the opposite angles, each of these is 45. So I've got 45 going all throughout my square. All right, moving on to number 4. Now we're getting into some more algebraic concepts. We want to solve for the values that we have here. So first we have an isosceles trapezoid. One of the properties that we know in an isosceles trapezoid is that our base angles are congruent. So these 2 angles are base angles, as are these 2 angles. But I don't need to highlight those because there's nothing up here for me to work with. So the base angles are congruent, and the leg angles are supplementary. So using that information, I know that I can solve for y right away because I know that the base angles are congruent if one of them is 128 The other one must be 128 as well. Solving for x now, I'm going to use the fact that we found this one to be 128, and I know that it's supplementary with the x, so x plus 128 equals 180. My missing value for x is 52. All right, number 5 for the kite. We have angles inside the kite, and we've got some diagonals. We know that in a kite, one of the properties is that the diagonals are perpendicular. And with that, we end up having a 90-degree angle right here. From here, we end up seeing, okay, well, I've got a 90-degree angle, a 2x, a 10x minus 6. These are 3 angles within a triangle. And again, we're going to pull on the information that we know that the sum of the interior angles of a triangle adds up to 180. So I can take my 2x plus my 10x minus 6 plus the 90 and set it equal to 360. I never use the 3x here. You will see problems that have information that's extra. Stuff that's just in there doesn't mean it's wrong. We just don't always need to use everything that's given to us. So going through and solving, we have 2x plus 10x is 12x, negative 6 plus 90 is 84, that equals 360. So 12x equals 96 because I subtract 84 from both sides. So x equals 8, and that is my value. X equals 8. All right, looking at number 6 now, we are told that AC, one of the diagonals here, equals 2x plus 3, and BD, the other diagonal, equals 4x minus 5. So one of the properties in a rectangle, which is the figure that we're dealing with, is that the diagonals are congruent. So with congruent diagonals, we can set these two values or expressions equal to each other. So 4x minus 5 equals 2x plus 3. Going through and just solving for x, if I subtract 2x from both sides and add 5 to both sides, we get 2x equals 8. Divide both sides by 2, x is going to equal 4. All right, moving now to number 7. With number 7, we have BE is 12, so that's part of a diagonal in this rectangle, and AC, this entire piece, is 2x plus 4. So again, I know that in my rectangle, the diagonals are congruent and they bisect each other, which tells me that all 4 of these pieces are congruent. So if all 4 pieces are congruent, I know that this must be 12, this must be 12, and this must be 12. So really, this entire length is 24. So the whole diagonal length is 24. But I also know that it's 2x plus 4. So I can set 2x plus 4 equal to 24 and just solve for x. So subtract 4 from both sides and divide both sides by 2. X equals 10. All right, for number 8, we have a parallelogram. One of the properties in a parallelogram is the fact that my opposite angles are congruent and my consecutive angles are supplementary. So if I take my look at my opposite angles here, I've got 2x equals 12y plus 8. These opposite angles are the same, so I can set them equal. But I don't like that. I'm dealing with 2 separate variables, and with that, there's nothing really much that I can do to solve for x and y. What I want to take a look at is my consecutive angles here. And I'm picking these 2 over these 2, because if I pick these consecutive angles, and I know they're supplementary, I would have 2x plus 5y plus 2 equals 180. I would run into the same problem. I've got 2 different variables when I really only want to work with one. That's why I'm picking these consecutive angles, because I know that they're supplementary, and now I just have 12y plus 8 and a 5y plus 2. I'm only dealing with the variable y. So I can say that 12y plus 8 plus 5y plus 2 is going to equal 180. Consecutive angles, if you add them up, they are supplementary. They add up to 180. So now I'm just going to go through and solve for y. 12y plus 5y is 17y. 8 plus 2 is 10. Subtract 10 from both sides, we get 17y equals 170. So divide by 17, we get y equals 10. y equals 10. That's going to be helpful for us because if I take a look, I know that if y equals 10 and I have the variable y in this equation, I can substitute 10 in for y. So I can have 2x equals 12 times 10 plus 8. And now I'm only dealing with one variable. So solving for x, I have 2x equals 120 plus 8, which is 128. 128 divided by 2, I find that x equals 64. All right, moving on to our rhombus for number 9. I again know that the diagonals in a rhombus are perpendicular, and that's going to be helpful because that tells me that this angle here is 90. I've got two expressions in place of these two angles, and I know that if I have this triangle here, so seeing as just like with number 5, we ended up having a 90-degree angle and two expressions, I know that all three of these angles in a triangle must add up to 180 degrees. So I can take 5a plus 4, 8a minus 5, plus that 90 that we found because we know the diagonals are perpendicular, equals 180 degrees. Solving for a, 5a and 8a make 13a. 4, negative 5, and 90 make 89, and that equals 180. Subtract 89 from both sides, I have 13a equals 91, so a equals 7 by dividing 13 from both sides. All right, number 10, we have a rectangle. So a rectangle in number 10, I know that all four of my outer, or I guess inside interior angles of my rectangle, these ones here are all 90 degrees. And I want to solve for x. Well, we're going with that problem again. We've got a triangle inside of our rectangle, and we know that the interior angles of a triangle all add up to 180 degrees. So I can find 3x plus 2x plus 20 plus 90 equals 180. 3x and 2x makes 5x. 90 and 20 is 110. Those equal 180. Subtract 110 from both sides. 5x is 70. Divide both sides by 5. X is 14. X equals 14. All right, 2 more to go. Number 11, we have a parallelogram. One of my properties of a parallelogram is that my opposite sides are congruent. So I have 3 expressions. I'm going to use the 2 that I can set equal to each other, the 2 that are congruent. So 5x minus 18 equals 2x plus 12. So we have to be careful in seeing when we set things equal and when we add things and set them equal to 180. Always do one or the other. We have to know when to do which. All right, so when I've got these congruent pieces, I know congruent means I can set equal. Now just solving for x, subtract 2x from both sides and add 18 to both sides. We have 3x is 30, so x equals 10. X is 10. All right, our isosceles trapezoid. We are told that FH, this whole thing, is 7, and EG is 4x minus 17. One of the properties of the isosceles trapezoid is that the diagonals are congruent, meaning I can set those values equal to each other. So 7 is going to equal 4x minus 17. If we add 17 to both sides, we get 24 equals 4x. Divide both sides by 4, 6 equals x. And then I can just reflect that and say x equals 6. All right, so we've now gone through the entire back page of the Topic 22 packet, 1 through 12.